Coding categorical variables can change the way we interpret the results of a linear regression. In the example above, we used effect coding for trial type. Now there are three main types of coding. Let's look quickly at our data. So our effect-coded trial type coded congruent trials as negative 0.5 and incongruent trials as positive 0.5. Let's add two new codings to our table. So we'll use the mutate function and we'll code trial type with some coding. So this is where you code one level as positive 1 and the other as negative 1. So we can use this recode function again, and we're going to recode the trial type column and make congruent equal to positive 1 or negative 1. Since we predict it'll be the smaller number, let's give it the negative code. And incongruent positive 1. So here, instead of negative and positive 0.5, we have negative or positive 1. We can also use what we call treatment coding. You might have heard it referred to as dummy coding, where we set one of our values as a baseline value. We'll set congruent as our baseline value, 0, and then your treatment effect is set to 1. Now this doesn't really make sense. Congruent and incongruent don't really have a baseline or a control group and then a treatment group, but we can code them in this way, treatment coding. And so that sets these to 0 and 1. Let's redefine the table dat here. So now we can rerun our linear model. So my LM, let's rerun the effect-coded one. So we're predicting RT based on the effect-coded trial type. And look at the summary. Now remember, this is the same as before. Our intercept is approximately what we simulated, the 800 millisecond value. Our trial type, the difference between congruent and incongruent trials, was 50 milliseconds, and we've gotten about that. And our standard error of the residual is what we simulated. Now we can look at treatment. So our treatment coding. Change that. Remember, this is where congruent trials are coded 0 and incongruent trials are coded 1. So they're still 1 unit apart. But here, this changes the value of our intercept. It's now 778. That was our predicted value for our baseline type. So this will be for congruent trials. And then our estimate is the same. So incongruent trials are 42.9 milliseconds slower, or added on to our intercept, which now, instead of representing the mean for all trials, it represents the mean for the baseline or 0 coded, so the 0 coded category. When we use sum coding, these are now 2 units apart, and actually the effect that we simulated will be in essence cut in half. So let's look at that. If we use sum coding, positive and negative 1, then this keeps our intercept being representative of the mean value. But then the estimate is the amount that you add or subtract from the intercept for each of your categories. So our estimate here is half the size because you need to multiply it by 1 and add it to the intercept for incongruent trials, multiply it by -1 and add it to the intercept for incongruent trials. Whereas when we had effect coded, you had to multiply the estimate by 0.5 or -0.5 before adding it to the intercept. So, to recap, when you effect code things with positive and negative 0.5, if it's a 2-category factor, your intercept represents the grand mean, and the effect represents the size of the difference between your 2 categories. If you treatment code something with 0 and 1, your intercept represents the mean for the 0-coded category, and then you add on the effect to that intercept to get the mean for the other category. So your effect is still the difference between the 2 categories. When you sum code things with positive and -1, your intercept is back to being representative of the mean for the overall set, but the estimate itself is half the size of the difference between the 2 categories for your factor. It is the difference between the intercept and each of the categories. So how you code your data determines what these numbers are. It doesn't change the p-values here. The p-values for whether or not the effect of trial type is significant will be the same. We can see here they're very small, but say the t-value is 6. It's also 6 here, even though these are different estimates, and also 6 here. And the intercept p-values will change because you're testing here the intercept is the grand mean different from 0, versus here with sum coding is the grand mean different from 0. But for treatment coding, we're checking to see is the mean of the 0-coded category different from 0. So is 778 significantly different from 0? We'll have a different t-value for that and a different p-value because it's a different question. So you need to set up your analysis based on what the question is you have, and then interpret your estimates in light of the way that you set it up.